In this tutorial, we are going to look at organic chemistry, and our focus today will be on alkanes. So let's get started. We're looking at alkanes. So alkanes are just saturated hydrocarbons. Okay? These are saturated hydrocarbons. When you're talking about hydrocarbons, these are compounds that contains only carbon and hydrogen. Only these two elements, or atoms rather. This is what forms hydrocarbons. So we've defined what alkanes are. Let me give an example of an alkane. We understand that alkanes obey the formula of CnH2n plus 2. Let me give an example of ethane, or methane rather, the simplest one. So methane has one carbon, right? Meth means 1 from our prefix. We've done the introduction of organic chemistry. We said that meth means 1, so we put 1 there, so it will be C1H, that will be 4, so we'll just get CH4 like that. So that is methane. So methane is an alkane. That is an example of an alkane. Let me give another one, or before I can move on this methane, you can even draw it using Meticulous structure. You just draw it like that. Expanded structure, that is Meticulous structure, whereby you get to show the bonds involved. So this is methane. You can even find the hybridization. You see that this methane is bonded to 4 different things, right? 4 things rather. So the hybridization of this carbon is sp3. Okay, let's look at another alkane. Let's have maybe ethane. Ethane is C2H6. From the formula we said Cn H2n plus 2. Eth means 2, so you just get to substitute 2 there. It will be C2. There we substitute 2, so it will be 2 times 2, that is 4, 4 plus 2, that is 6, so it will be C2H6 like that. So that is ethane. It's an alkane. Now what happens if we get to remove one hydrogen from an alkane? So when you remove, this is an alkane, I have an alkane, then I remove one hydrogen, so minus one hydrogen. So what I get to have is actually an alkyl. Okay, I'll get to have an alkyl group. Let me give an example. Let's say you have methane CH4 minus one hydrogen. So what I'll get is CH3, right? The hydrogens remain 3. So this is, it was an alkane, which is methane. It was methane, but it has turned into an alkyl, so it will be methyl like that. Let's have another example. Let's say I have, this is, let me use bond line structure. This is what? Propyl, because there are 3 carbons there. There's 1 carbon there, 2 and 3. So this is propane, right? This is propane. So propane propane is C3H8. This is propane. But once I get to remove one hydrogen, the name will change. So if I remove one hydrogen, it will be C3H7. The name will change from propane to become an alkyl. So it will be propyl. Like that, right? Let me give an example of another one. Let's say I have, this is my ethane, right? Let's say this is my ethane. Ethane is just a straight line, so there's one carbon there too. This is ethane. But what happens if I get to remove one hydrogen? So let me connect this to a parent chain. I remove one hydrogen, so it will be 1, 2. I've removed one hydrogen, so it will remain ethyl, like that. Okay, so this will be ethyl, so I'll get to have CH3 CH2. So what about if I have a structure of this kind? So let's say I've connected it to the certain parent chain there. So I have 1, 2, 3. But I've removed one hydrogen. 3, it is propane, right? So from propane, which is C3H8, when I remove one hydrogen, I'll remain with C3H7, okay? And this is connected to a certain parent chain. So this would cease to be propane, but rather to be propyl as an alkyl, okay? What if I have a certain structure of this kind? Then it is bonded to a certain parent chain, right? It is connected to a certain parent chain. So I can get to number this as 1, 2, or I can say 1, 2, going up, whichever way I choose to number it. Okay, so 1, at carbon number 1, I can see that as carbon number 1, if I number it like 1, 2, so let me just take one numbering. So 1, 2, there. So this is an ethyl. Okay, so it is an ethyl. Then this one also. So this is the route I'm taking. So this one will be a substituent. So this one, because it has just one carbon, this is the methyl. So when I want to name this compound, this structure, I'll say 1. So there's a substituent will be methyl. So 1 methyl, as carbon number 1 there is methyl. Then 1 methyl connected to ethyl. I'll consider this as the parent. So it will be 1 methyl ethyl. I'm considering ethyl to be the parent, okay? The parent chain. But this 1 methyl ethyl can also be called an isopropyl. Why? Because it has 3 carbons. 1, 1, 2, 3. It has 3 carbons. And because it is forming in this structure, we can call it rather as isopropyl. Let me have a certain structure. Let's say I want to name this structure now. Okay, let me rub this part. Let me say I want to name this structure. So when you're naming this structure, the first thing you need to consider is to identify the longest carbon chain. You number it, the longest carbon to carbon chain. That is what you need to identify. So the longest, if you start numbering, you can number from either side. So 1, 2, 3, 4, 5, 6. You can't go here because you have, this is not the longest. If you say 6, 7, that is not the longest. So you probably go this way. So 6, 7, 8, 9. So a compound with 9 carbons, it is nonane, right? This is a saturated, there's no double bond, it's a saturated alkane. So that is nonane. But at carbon numbers 6, if we number it in this way, we'll discover that there is a methyl group here. There's a methyl because there's just one carbon, then bonded to 3 hydrogens like that. So that is a methyl group, as we discussed earlier. So we have a methyl group. But numbering from left to right, we'll discover that the methyl group is at 6. But what you need to do here, you can number it in the backward again. So 1, 2, 3, 4, 5, 6, 7, 8, 9. When you number it from right to left, you discover that this methyl group is actually at carbon number 4. So what you need to consider now is the numbering, which is giving the substituent to have the lowest number. So in this case, we'll take 4 instead of numbering it from left to right as having the substituent, the methyl group, at 6. Instead, we'll have 4. So there's 4 methyl there. So just now connect. So the name will be, so the substituent is methyl. It is at position number 4. So this 4 is showing the locant. The locant is just the position, okay, the location. So the methyl is at position 4, so it will be 4 methyl. Then the parent name is nonane. So that is the name of this compound. Let's look at another one. Let's say I have a compound of this nature. Like that. So if I number it in this form, 1, 2, 3, 4, 5, 6, 7, 8, 9. I also number it backward, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. Let me remove one part. I think let me write a different one. 1, 2, like that. So then there I have that. Okay, so if I number this 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I have the parent name will be decane, okay, but we have the substituents at position number 3 and position number 4, and because this has just one carbon, it's a methyl group. Even there it's a methyl group at position number 4. So what will be the name of this compound? So the name will be, we indicate first the position. At position number 3 we have a methyl, but at position number 4 again we have a methyl, so it will be 3,4. Then because there are 2 methyl, we're going to use the prefix di, okay, because there are 2 methyl as position number 3 and number 4, we're going to use the prefix dimethyl because there are 2. If there were 3, we would have used tri. If there were 4, we would have used tet. Okay, just like that. So it will be 3,4 dimethyl. What is the parent name? The parent name is decane. So it will be 3,4 dimethyl decane. So that is how you name this. But what if you have a compound of this kind, whereby at this position you have this ethyl group. This is an ethyl group because it has 2 carbons. Then I also have this. What is the name of this compound? So the name of this compound would be, I number it, so 1, 2, 3, 4, 5, 6, 7, 8. So the parent name is actually octane. Now let's consider now the substituents. The substituents will be, at position number 2 I have a methyl. At position number 3 I have a methyl. At position number 5 I have an ethyl. But you see, we need to number it also in the opposite direction. So 1, 2, 3, 4, 5, 6, 7, 8. So which one is giving the lowest first substituent in this compound? So you get to see that at position number 2 we have a methyl, and also at position number 3 we have a methyl, and at position number 5 we have, so 1, 2, 3, 4, 5. At position number 5 we have an ethyl group. Okay, we have an ethyl group at position number 5. So what would be the name? If I take this route, I'll have the ethyl group as 1, 2, 3, 4. I'll have the ethyl group at position number 4. So in this case, what you get to do, so you get to consider which one will give the lowest number, the first substituent which will have the lowest number. So in this case, we'll discover that the one which will have the lowest number is actually methyl at position number 2. We won't number it from the backward direction, like following the backward direction, because we'll have the methyl group quite right at position number 4, but we have the methyl group at position number 2. So we get to consider the numbering from left to right. So what I have is that when I number it from left to right, so let me just get rid of this. When I number it from left to right, so 1, 2, 3, 4, 5, 6, 7, 8. So at position number 2 I have a methyl. At position number 3 I have another methyl. At position number 5 I have this structure which is an ethyl, because methyl has a letter M, ethyl has a letter E as the first letter. Okay, we get to start with the one which has the first letter of the alphabet, which is coming first. Okay, the letter which is coming first in the alphabet, which is E. So we'll start with ethyl, then we'll go to methyl. So where is ethyl? Ethyl is at position number 5. So we'll start with ethyl. So we're going to say 5 ethyl, right dash. Then at position number 2 I have a methyl, and at position number 3, so to separate this I'll just put a comma, then I'll say 2, 3. Then I have 2 methyl. Because I have 2 methyl, I'll say dimethyl. Then I'll put the parent name octane. So this is how you get to name this compound. It is wrong to say 2, 3 methyl 5 ethyl octane. It is wrong to say that because E comes first than M. So you start with E. So it will be 5 ethyl, then you go to methyl. Okay, so that is how to name this compound. Let's have another one. Let's say I have a compound of this kind. Okay, I have this compound and we've been asked to name it. How can you name this compound? So, of course, I'll need to number it. I'll start 1. Let me start from here. 1, 2, 3, 4, 5, 6, 7, 8, 9. If I go in this direction, I'll have 9 carbons. But I can go in this direction from 8, 9, 10. This is giving the longest chain. So the longest chain is not the one with 9 carbon, but rather the one with 10 carbon. So this is the cane. This is the cane. So how do you name this compound? So at carbon, we'll start in this manner. We'll start from the left to right. So I'll say 1 here, 2 here, 3, because the whole essence is to give this substituent a smallest number. So 3, then 4, 5, 6, 7, 8, 9, 10. If I go in from right to left, I number it from right to left, I'll discover that the substituent is at position number 9, of which I do not want to give it a highest number, instead a lowest number, which is 3. Okay, so you number it from left to right. So I'll say 1, 2, 3. At position number 3, this is a methyl. I have a methyl group. So it will be 3 methyl. Then I have the parent, which is the cane. So this is how you can name this compound. So the trick part there is to find the longest chain. The longest chain must not always be the straight chain, but it might be branched at some point. So you just need to find the one which is giving the highest number. So what if I had a certain molecule or compound rather of this kind? Okay, I have this. Okay, what if I had this particular molecule and we've been told to name it? This is the compound I have. How can I name it? Okay, so I want, okay, just like this. like that. Okay, now let's name it. So I'll number it in this direction. If I number it, I'll have 1, 2, 3, 4, 5. I can't go in this direction because it will give the smallest number. 5, 6, 7, 8, 9. If I go this way, I'll have 10 there. Okay, in fact, let me even reduce the number of carbon, because we might have 12, which is the decane, and that is not much of our interest. So let me start from here. So 1, 2, 3, 4, 5, 6, 7. If I end here, if I go this way, I'll have 8. But this is not a longest chain, so instead I'll go this way, which is 8 there, then I'll have 9 there. So the substituent we have, I have a substituent there, a methyl. I have a substituent there, a methyl, and another substituent there, which is a propyl. So which is, yes, a propyl. It has 3 carbons. Okay, that is a propyl. So what if I numbered it in this way? So 1, 2, 3, 4, 5, 5 there, 6, 7, 8, 9, 10. Actually, we have a longest chain in the opposite direction, not the one which is giving 9. Okay, so the longest chain is this one. So 1, 2 there, 3, 4, 5, 6, 7. Instead of going 8, 9, I'll go in this way. So 7, 8 there, 9, 10. So this is now the longest continuous carbon chain. So because this is the longest continuous carbon chain, so I'll consider this as a substituent. This is an ethyl group. A substituent. This is a methyl group. This is also a substituent, and that is a substituent. So at position number 7, I have an ethyl. At position number 6, I have a methyl. Again, at position number 3, I have a methyl. But when naming it, I'll start with the first letter, the letter which is appearing first in the alphabet, which is ethyl, not methyl. I'll start with ethyl. So it will be at position number 7, I have ethyl. So it will be 7 ethyl. Then at position number 3, I have methyl, and at position number 6, so 3,6 methyl decane. So this is how to name it. So it will be 7 ethyl 3,6 methyl decane. So that is the name of this compound. Now what if you had 1, 2, 3, 4, 5, 6, 7, 8? What if I have this compound and 1, 2, 3, 4? Okay, let me. So 1, 2, 3, 4, 5, 6, 7, 8. Okay, so what if I add this compound there? I have a methyl. There I have this. Okay, I have this. So this is the compound I have. So let me number it. The one which will give the lowest number of subsequent. If I name it 1, 2, 3, I'll have at 4, 5, 6, 7, 8. Okay, let me name it in the opposite direction. So 1, 2, 3. It's still at 4. I'm having a substituent at 4. So how can I name this particular compound? So let me name it in this way. So 1, 2, 3, 4, 5, 6, 7. Or I name it backward. 1, 2, 3, 4, 5, 6, 7. So which one should I take in this case? At position number 4, I have a methyl. At position number 5, I have an ethyl. So in this case, where you have two subsequents appearing at the same position, like appearing at position number 4. Actually, I have 1, 2, 3, 4. How is my numbering? Let me number it again. So 1, 2, 3, 4, 5, 6, 7, 8. Let me use a different ink so that I get to distinguish this. Okay. So for this one, I'll start here. 1, 2, 3, 4, 5. Okay, this is not my question I want to ask. So 1, 2, 3, 4. Okay. Actually, it's the same one. I want to give a situation whereby you have this. Okay. So it's just the right one. So 1, 2, 3, 4 there. 5, 6, 7, 8. So I want to take a situation whereby I have two substituents. They are appearing at the same time. If I number it in this manner, the substituent I have ethyl at position number 4. If I number it in this direction from left to right, I have a methyl at position number 4 also. So how do you get now to find the name of this compound? So to find the name of this compound, or how do you arrange this substituent? So it starts with the one which has the letter appearing first in the alphabet, which is methyl, not ethyl. So you give the priority to methyl. So the name of this compound will now be, the name will be, it will be 4 ethyl. So 4 ethyl. Then at position number 4 again, I have another substituent which is methyl. Then I get to put the parent name, which is actually, the parent is octane. So this is the name of this compound. So it is 4-ethyl, 4-methyl octane. That is how you get to name this compound. Okay. Now, what if you have a certain alkane? Now, this alkane has a certain group, okay? Has a certain group, let's say an alcohol, or it might have a certain group, let's say a carboxylic acid. Those are what we call fractionalized alkanes. So let's look at what we are calling functionalized alkanes. So what are functionalized alkane? So there are these alkanes which are now influenced by other atoms. They are influenced by other atoms. Their physical properties, their chemical properties, they are being influenced by other atoms. Those are what we call functionalized alkanes. So they can be influenced by, let's say, an alcoholic group, okay? An alcohol group, or maybe a carboxylic acid, like that. Or it could be influenced by an amine group, okay? Amine, how do you even write amine? So it's NH2, right? Yeah, an amine group, like that. So those are what we call functionalized what alkane. So how do you get to name these compounds a functionalized alkane? Let me give an example. Let's say I have this compound. Let's say I have a compound like this. Let's say I have OH there. Then I have this. Okay, so how can you name this compound? According to the priority, we've discussed the priority table. If you didn't get to have a chance to learn about the priority table, you can just check out our video from the channel. You can just search priority table Meticulous hub. It will bring the video so that you get to understand the priority table. So I have this compound. How can you name this particular compound? So to name this particular compound, we are going to give the priority, the one which has a higher priority is actually this compound, this group, which is a carboxyl group. So the carboxyl group has a higher priority as compared to an hydroxyl group, or an alcohol rather. So you get to give the priority to this carboxyl group. So how is it going to be? So it will be, you name this as, we have carbon number 1, 2, there are 3, 4, 5. So this is the actual alkane with 5. It is known as pentane. But because of this group, which is a carboxylic group, it will be influenced. The alkane, the pentane, will be influenced by this, the carboxyl group, the group which we have of an acid. Okay, so this OH now will become the substituent, and from the previous tutorial we had, we said that if OH becomes the substituent, it ceases to be called an alcohol. It is a hydroxyl. Okay, so what is the name of this compound now? So this carboxyl is always at the first. You can't say this is at position 1, the carboxyl group is at position 1 or 2. It's always at position number 1. So even if you don't indicate the position, so you always start from the one with the highest priority in the priority series or priority table. So this will be 1, 2, 3, 4, 5. So the name is actually pentanoic acid. Now you see, this is the parent name. So at position number 5, we have the hydroxyl. So you indicate as 5. Then you say hydroxy. Hydroxy pentanoic acid. So this will be the name of this compound. Let's look at another example. Let's say this chain alkane this alkane chain I have is this. It is influenced by an alcohol. Then at the end, let's say I have an amine group like that. Okay, so how do I get to name this compound? So we discover that alcohols have a higher priority as compared to amine in the priority series. So I'll give the priority to alcohol as compared to amine. So I'll say this is carbon number 1, 2, 3, 4. So once I give the priority to alcohol, I didn't even to start naming from an alcohol. So it will be 1, 2, 3, 4, 5. So at there are 5 carbons in this chain. So it is 5 carbon. It is pent, so it will be pentano. But at position number 5, I have this amine group. You said that if an amine is a substituent, if an amine is a substituent, the name we call it an amino. Okay, so it will be 5 amino. Okay, so for this one I'll indicate the position of OH, the alcohol, because this alcohol can even be here. Okay, so I need to indicate that it is at position number 1. So I'll put 5 amino 1 pentano. That's an alcohol, so it must end with the OL. So this is the name of this compound. It is 5 amino 1 pentano. Or you can even write it as, so let me use a different ink. Okay. Let me use a different ink. So how can you name this? You can also write it as 5 amino pentane. But at position number 1, that's where I have this alcohol, so pentano. That is where I have the alcohol. So it is very important that you indicate the position. So this is all about the alkanes. Thank you for watching.